All right, guys, so let's finish this off with verifying trig identities. So we already went ahead and did all the simplifying. We went through all the trig identities. So now let's go ahead and verify them. So you can see what we have here is we have some trig identities on this side, trig functions on the left side, and then trig function on the right side. So what you want to do is you want to prove that this side is equal to this side. So you're going to manipulate one of the sides, and that's a key here. Don't work both sides of the equation. Manipulate one side of the equation to equal the other. So think of this equal sign as a wall that you can't cross, and you want to manipulate one of the sides, typically the side that is the most complicated, and make it equal the other side. Do not treat this like an equation where you're going to add and subtract things over to the other side or multiply and divide. Think of this equation sign as a wall that you can't cross and get this side to equal this side. So looking at what we have here in number 20, let's see what we can do. Now obviously this is just tan to the fourth x, so there's really not much that we can do with this. We're probably going to manipulate this left side. Well, when we were simplifying, one of the strategies was changing things to sines and cosines. Well, that's not really going to help us here because this is the tan to the fourth x. So we don't necessarily want to change that. Well, what can we do? Well, if you look at cosecant squared x minus 1, think about your Pythagorean identities, and that is equal to cotangent x. So let's go ahead and do that because we have a tangent squared in the top. So then by changing out this identity to a cotangent, we're getting closer to just tangents. That's equal to tan to the fourth x. Now what else can we do? Well, cotangent x, the reciprocal of that would be 1 over tan squared x. So I can say that my tan squared x up in the numerator, cotangent squared x is equal to 1 over tan squared x. And go ahead and write this out here on the other side. And now what can I do here? Well, I got tan squared x divided by 1 over tan squared x. Well, when you divide with fractions, what do? You flip and you multiply. So this becomes tan squared x times tan squared x over 1, because you flipped and multiplied, is equal to tan to the fourth x. And then, of course, when you multiply, that gives us tan to the fourth x is equal to tan to the fourth x. So that is true. We just verified that. Now, it's important to write out all these steps. You can't really skip steps when you're verifying. It's like a proof, so you can't do that. You have to justify everything that you're doing. All right, so let's look at 21 here. So we got secant negative x and cosecant divided by cosecant negative x is equal to negative tan of x. Well, let's go ahead and take care of this in here using the even and odd identities. So secant of negative x is equal to just secant of x, and then cosecant of negative x is equal to negative cosecant of x using your even odd identities. So now what else can we do? Well, if we can get some kind of relationship here with a sine over a cosine, and we know sine over cosine is equal to tangent, that's probably what will work for us. And we know that these are the reciprocal functions of sine and cosine. So let's go ahead and do that. So secant x is 1 over cosine x. And then cosecant x is 1 over sine x. And of course, we get the negative there. So it's negative 1 over sine x. And that's equal to negative tan x. Now, just like we had over here, we're dividing fractions. So we're going to flip and multiply this. So that would be 1 over cosine x times negative sine x over 1 is equal to negative tan x. And now when you multiply that, that gives you negative sine x over cosine x is equal to negative tan x. And of course, sine over cosine is equal to tangent, and then there's the negative. So negative tan x is equal to negative tan x. And that is good. All right, let's take a look at number 22. All right, so we got 22 and 23 here. So looking at 22, we want to verify that this is equal to cosecant x. So probably going to work this side, obviously, because the right side is just cosecant x. So looking at the tan of pi over 2 minus x, I'm thinking, cofunction identity here. And tan of pi over 2 minus x is equal to cotangent. So I'm going to go ahead and replace that with that identity. So I get that. And now cosecant x we know is the reciprocal of sine. So we're thinking that's going to be 1 over sine. So we probably want to somehow get this to be 1 over sine. So let me see about changing some of these over to sines and cosines, and hopefully things will cancel out. Well, cotangent is equal to cosine over sine x. We know that from the quotient identities. And then with secant, that's going to be multiplication. Secant is the reciprocal of cosine, so that's 1 over cosine is equal to cosecant x. And now since we're multiplying these, I can go ahead and reduce because I got the cosine up top here and in the bottom. So if I cross that out, that leaves me with 1 over sine x is equal to cosecant x. And of course, 1 over sine x is equal to cosecant x. So that is good. All right, looking here, we got tan x plus cotangent x is equal to secant x times cosecant x. Adding here is probably going to be more work to manipulate to this side over here. So we're probably going to work this side, makes more sense. So again, the secant and cosecant, they're reciprocals of sine and cosine, so I'm probably going to go ahead and change these up right here. So I'm going to say that tan x is equal to sine x over cosine x plus cotangent x is equal to cosine x over sine x. Write the rest here. So now if I want to add these two together, because again, this is a multiplication here. So if I want to get these two together, then I somehow going to need to find a common denominator, and that's exactly what I have to do. So if I got a cosine x here and a sine x here, my common denominator is going to be sine x times cosine x. So I'm going to go ahead and write that out. Write my common denominator. And I'm going to go ahead and write this side out too. Now I already have a sine x here, and I already have a cosine x here. Remember when we were finding the common denominators, we're doing this with the simplifying problems, you got to correct for the numerator. So in order to make this, I got to multiply by sine x. So that's how I'm going to correct for that. And then in order to make this a sine x cosine x, I got to multiply by cosine x in the top. And then by doing that, now I have my common denominator. I can go ahead and combine these into one fraction with this plus this over my common denominator. Well, sine x times sine x is sine squared x plus multiply cosine x times cosine x is cosine squared x over my common denominator. And that's going to equal, we hope, secant x cosecant x. All right, well, looking at this here, hopefully you see up in the top, sine x squared plus cosine x squared, Pythagorean identity, that is equal to 1. So then we can say that this is 1 over sine x cosine x is equal to secant x cosecant x. Hopefully you see where this is going. So if I have this right here, this is 1 over cosine, and this is 1 over sine. And that's kind of what I have here, but I got to split this off so I can show that. So this right here is the same thing as saying 1 over sine x times 1 over cosine x is equal to secant x cosecant x. And then, of course, 1 over sine x is equal to cosecant x. And then 1 over cosine is secant x. And that's equal to secant x times cosecant x. Now, I know they're the reverse, but it's multiplication, so it's commutative. You can, if you want to write it out so that it's exactly the same, you can say this is secant x cosecant x is equal to, and we are Good. All right, so let's go ahead and take a look at number 24. All right, so looking at number 24, you can see we're gonna have to simplify this to get it to equal to cosecant theta. So what I'm gonna do here is I already got some signs and I got a sine and cosine, so I'm gonna change the cotangent to to cosine over sine. So when I do that, I get sine theta plus cosine theta times cosine theta over sine theta is equal to cosecant theta. So now if I go ahead and just multiply this together, that's going to give me sine theta plus cosine squared theta over sine theta is equal to cosecant theta. So now what can I do? Well, I need to get these together. I need to add them, so which means I need to find a common denominator. Well, my common denominator is just going to be sine theta. So if I do that, I got sine theta here plus, I'm not going to have to change this side because it already has the common denominator. So all I really have to do is correct here. Now I already have a sine theta, and in order to get that to be sine theta over with a common denominator of sine theta, I need to multiply the top by sine theta. So when I do that, I can go ahead and add these two together into one fraction with the common denominator. So sine times sine, that's going to be sine squared theta plus, I have my cosine squared theta over my common denominator is equal to cosecant theta. So now again, this is starting to look familiar. You got sine squared theta plus cosine squared theta. That is equal to 1 using the Pythagorean identity. So 1 over sine theta is equal to cosecant theta. And of course, 1 over sine theta is equal to cosecant theta. So this is verified. All right, so I'm going to break this up into another part just for time. So in the next video, we'll pick up with number 25.